my favorite things, game development and programming. This is going to be a good one. I really love it. We're going to jump into Unity. We're going to do some cool stuff. Let me give you a quick overview of what we are doing today. Let me get this going and show you. All right, so this is Programming in Unity, sponsored by Boca Code and Palm Beach Tech. Please check us out at bocacode.com. Join our Slack group. It's a single click. If you're on Slack, go to bocacode.com, hit Slack. Palm Beach Tech, also awesome Slack community, palmbeachtech.org/Slack. Can you tell I like Slack? Programming in Unity, what we're going to cover today, we're going to look at how to control player movement. We're going to do some camera tracking. These are real basic things. We're going to just start with a real basic scene. We're going to do some object rotating, some collision detection, and scoring. So let's jump over and see what that might look like over in Unity. So what I've done here is I've set up just a very basic scene. When you start in Unity with a sample scene, you typically have a camera, you have a light in your scene, a directional light in your scene, and then what I've added is I've just used some primitives. Just under game object, 3D object, I've got a plane, and that's the big flat purple area that you see. I colored it purple, so Boca Code purple, or indigo. I've added a sphere, and that is going to be a rolling ball. That's going to be our player. I've added a couple of cubes that we're going to interact with, and then I've also added some cubes that I've used to create the walls around the playfield, just to keep our ball from falling out. So this is just simple setup, just with some basics. And if we play the scene, you can see the view from the camera, and if I interact with my player, I get nothing. Oh, also just to see, I also have a score text here. So nothing going on, right? So there's nothing to play. Everything is just static and just sits around. So what we want to do is we want to go to our player object here, which we can zoom in on, and we want to add some code to this. So we're going to jump right in and we're going to add some code. And if you're not familiar with Unity, basically this hierarchy here keeps track of inside my scene, what are all the pieces. So you can see player here. I've got this yellow cube. I've got this collectible item here, which we're going to get to. I have this special thing called a canvas, which if we double click to zoom out on, that's actually where, what gets laid on top of the camera. It's kind of a weird object. With our text object, that's our score, which you can actually see, you can move it around right like that. We've got the board here, which basically what I did was I had the board, which is the plane, and then I put the walls here just as children of the board. So what it means for those to be children is, if you move one thing around, it moves them all around. So then directional light kind of gives you that outdoor casting shadows feel, and then our camera. And what we're going to do today, we're going to take our player, we're going to make it move when we move the we're going to make it move when we move the access our controls on our keyboard or mouse. We're going to then make the camera follow our player around. We're going, so that's the second thing we're going to do. Then we're going to actually start making we're going to make this collectible item rotate so it looks, cool and funky. And then we're going to start, copy that, make a bunch of collectibles, and add to our score. So it's a bunch of little scripting things, but I think you'll learn a lot as we go. So let's start off by making the player, by allowing us to control the player. Also, on the right hand side here, we have our inspector, which tells us about this object. We have down here at the bottom just all of the pieces of our project are organized, and we're going to try and keep things a little bit organized as well. You know what? I'm not even going to worry about that. Screw organization today. So let's do this. Our player, which is this sphere here, it has all of these components. There's the mesh, that's the shape. There's the mesh renderer that gives it its appearance, so we can turn it on and off, make it invisible. There's a collider, which we're going to be using in a bit, and I've added a rigid body to this. Okay, what a rigid body does is it makes it more of a physical object. It's not just a 3D object, but it's actually, it now starts to apply physics to it in Unity. And it's really easy. You just go to add component, right, where you get all these different components you can add, and you could just search for rigid body. You add that component there. Great, my trackpad just died. That's awesome timing. There we go. You add that component, and then you can do things like turn gravity on and off, control the mass of it. So, you know, a very light object will easily bounce off of a heavier object, that kind of thing. So Unity has all these physics built in. So just to give you an example, this object here, I have gravity turned off. So you'll see it's actually, when we get in there and look, it's actually floating just above the surface, whereas this cube has gravity on. It's sitting right on our plane. But let's jump into scripting. So to script, we're going to add a new component to our player, and it's a script, and we are going to just say add a new script. We give it a name. Let's call this player controller, and then it creates that script. It's creating it in, should be creating it in the background now. It should, yep, there we go. And now it added it as a new component to this. Well, that script doesn't do anything yet. So we can double click it. It'll open it over here in VS Code for us, and we can jump right in and start coding. So for those of you who aren't familiar with C#, which is, you know, .cs is C#. This is the language that we use in Unity, the preferred language. You can, I believe there's still some support for using JavaScript, but C# is the preferred language in Unity and pretty much in game development. And, you know, this using is basically just importing libraries like we do in any language. Then we're creating a, you know, class here that connects to our object, you know, our sphere object. And the class here will have the same name as the script file as the controller that we just added to our player controller. So we called it player controller with capital P, capital C. The file that's saved is player controller, capital P, capital C. And the component that was added to our sphere was also called player controller, capital P, capital C. All of those need to match. So if you change the name of a file or something like that, you could break this. So just keep that in mind, that the component that we added, the class here, the class name, and the file name all need to match. And it's a class type of mono behavior. And notice Unity put all of this stuff in here for me. I didn't write a line of this. We haven't written a line of code yet. We just said, hey, add a script, right? And this mono behavior class, which it, you know, so player controller is inheriting all these behaviors from mono behavior. And you don't need to know a lot about mono behavior, except that mono behavior has some built-in functionality. So it has some built-in methods. The first one is called start. So, and in C#, we put void before the name of a function if the function's not returning something. So there's a start method, which is called before this object is first rendered in the scene, right? And then there's an update function, which is called every frame. And what we're going to be doing is we are going to say, first of all, remember we added that rigid body? We want to connect to that. So before we get into these methods here, we're going to actually create some variables. The first variable we're going to create is just going to be a private variable, meaning it can only be accessed inside this script here. It can't be accessed from outside. And this is going to be of type rigid body, right? Oops, not a capital B, I forget sometimes. And we're just going to call it RB for rigid body. And where is it going to get this rigid body from? Well, the first time that this object is rendered on the screen, we're going to set RB equal to, and then we're going to say, and one thing I really like about C# and Unity is you don't have to specify this all the time like you do in JavaScript. You know, this dot get component. It knows that this is attached to that sphere. So what we can do is we can say get component, and what we're saying is the object that this component, that this player controller component, the sphere, is attached to, it has another component that I want of type, or called rigid body, or of type rigid body. So we just say get that rigid body component, right? If we jump back into Unity, we're saying, hey, on this object here, there's a rigid body component, right? This guy here. Grab that, set it to RB, okay? And the reason why is because this rigid body we can apply physics to. We can add forces to it. We can, we can do all kinds of things to tweak it, and that's what we're going to do. So now in update, which is called on every frame, what we're going to do is we're going to say, what we want to do is we want to get, imagine the user has a joystick, right? And that joystick has a vertical axis and a horizontal axis. And we want to see where they are in the vertical and the horizontal, and then we want to move our object along that same directional path as the joystick. I'm not using a joystick. I'm using the WASD keys or the arrow keys on my keyboard, but Unity already has this built in. So what I can do is I can create a new variable here, which we're defining in C#. You tell it the type of variable before you go, and we're going to say this is how much we want to move on the horizontal axis, and we're going to get from input, which is built into Unity, we're going to say get axis horizontal. And this is getting that like vector component of the horizontal axis of our joystick or controller. And I'm going to copy this line, but I'm going to change horizontal here in both places to vertical. Right? Little fun trick in VS Code. You can, have multiple cursors at once. It's very fun. So now we have, okay, here's how much it's pointing in the horizontal. Here's how much it's pointing in the vertical. And a lot of the trickiest thing to me about game programming is not actually the code. It's not learning C#. It's not understanding. The commands that we're giving are relatively simple. The trickiest thing, and the trickiest thing's not the physics, because Unity has all that built in. The trickiest thing is actually the vectors, dealing with vectors. That is the hardest part by far, in my opinion, of game development. And so, this all gets into vector algebra. Luckily for us, Unity has some tools that make it somewhat easier. So for example, and we're in 3D, so they have just like we said, float, we're going to create a vector 3, which is a three-dimensional vector, and we're going to call that vector movement, right? And how are we going to set that up? Well, we're going to use a vector 3 object that this takes now 3 parameters. It takes X, Y, and Z, and then it creates a component from it. So for the X, we're just going to use our move horizontal. Now for the Y, let me jump back over to Unity for a second, and notice that when we're looking at this object, the X is the red here. So that's the horizontal. The Z is the vertical, and the Y is normal to that, right? What, is up and down in the air. So we're kind of just looking at X and Z here in terms of controlling this horizontal and vertical, right? So if I move up, I don't want this thing to actually lift up off the board. I want it to move in the Z direction, right? So if I hit the up arrow, I want it to go that way, away from the camera, not up off the board, right? And levitate, right? We do this all the time, we say like, instead of saying like, oh, New York is north of Florida, we say New York is above Florida. It's up. I'm going up to New York. I'm going down to Florida. Really, you're moving horizontally along the ground. You're not moving vertically in the sky. So the Y direction here, which is vertically up and down, away from the ground, we want that movement to be 0. So when we come back in here, what we're going to put in for Y is 0. And we're just going to force that to be a floating point, not an integer, like we have these as floating point variables. So we're going to say we're going to move horizontal, whatever the controller is telling us to move horizontal, and we want in the Z direction, remember, this is the move vertical, right? And so I've got stuff on my screen that's blocking so I can't see. So now we have this three-dimensional vector. So how do we apply that to our game object, right? So what we're going to do is we're going to actually apply it to this rigid body RB, right? We're going to take the game object, the player's object's rigid body, which we've called RB here, and we're going to add a force. So remember, we've got this physics engine, so we could say just give it a shove, right? Push it in that direction, add a force. And what do we want? We want to push it in the direction that of this vector that we just created. So let's save that. We're going to come back and make some tweaks, but let's just save that and see what we get. I'm going to jump over to Unity, and it takes a second to switch over to Unity because what's happening now is it actually compiles that. Make sure there's no bugs. If there are bugs, we get them in our console, and it'll tell us down here at the bottom of the screen in red. We'll see some bugs here, but it compiled. No bugs, no problem. So now I hit play, Command P to play. And now when I hit the up arrow, my ball very slowly moves towards that yellow box, and I can move my guy around and go right through that. Notice that one doesn't have collision detection set up. We'll talk about that object later, but it's like really hard to get this thing to move. So it's moving way too slow. This is not a fun, exciting game, right? So what do we want to do? We want to add a new variable in here. We're going to make this public, and I'll show you why. And we're going to make it floating point, and we're going to call it speed. And what we're seeing is that's so super slow. So maybe we want to crank this up 100 times, right? So we're going to set speed to be 100, right? Now, we don't have to set this here, but we can. We can set a default here, but because it's public, it's actually going to be available to us in Unity in the inspector, as you're going to see, because we made it public. So now what we can do is we can just say add force movement times speed, save that, flop on back over to Unity. And now you can see in our player controller script, we have this speed here at 100. So we can access that, and without having to update our script and recompile, we can change the speed of our player. So let's hit play. Let's see what happens now when I go forward. Whoa! And now we're super zippy, right? Kind of the opposite problem. Oh, and our ball went flying off. So apparently 100 was a bit too much. So let's take this down. And since I'm a wimpy player, I'm going to take this down to around 6. I'm going to save my scene, hit play. And now I can control the ball. Maybe that's still a little too slow. But what we can do, we can actually come over here in the inspector while we're playing, change that number, and woof, now we've got real-time updating. And notice that the physics built into Unity, when I collide into this big yellow brick, big yellow block, it's actually, if I can hit it, so let's slow the roll, literally. And boom, collided. And you can see that the physics are somewhat realistic when we collide. Sorry, Alan. Alan said, I guess I upset Alan when I told him when I used the term vector algebra, right? So you don't really need vector algebra as long as you can, if this code here makes sense to you, what we wrote, then you're good to go. That's about as complicated as it gets here, having these vectors, in 3 dimensions. But if we're building a 3D game, you have to have some level of understanding of that. So maybe we can set our default here to 10 before we leave, and and now we're set. So now we've got the ability to control our player, which was the first part of what we wanted to do. So let's move on now. And in most games, coming back to Unity, there we go. In most games, the camera here will actually follow the ball, right? Or your player. Now, in a lot of games, your player isn't a ball. It's, maybe a person or something like that. And, so for a third-person type of game, a lot of times what you do is you take your camera and you'll just child it to the player, right? So this way, these two are now connected, and then as the player moves, the camera moves. But let's see what happens if we do that, if we try that in our game. And whoa, not so bueno, right? So what's happening there? As the ball rolls, the camera is flipping around, and that is definitely not what we want. So we can't just add our camera as a child to the player so that they're linked. We need to write some kind of script. So what we're going to do is we're going to come to our camera, and we're going to add a new script, and we're going to call this camera controller. So this is part 2, camera controller. And you see it creates a script, and I can move these scripts into a script folder if I want. I'm not going to worry about organizing my project right yet. Value your guys' time too much. So I'm going to come into this script here, and now, it's already set up for us. It's got the names, it's got the void and update and so forth. Actually, come to think of it, there's several other methods, and I want to go back to my player controller and fix something. Update is called once per frame. And so what happens is the faster your computer, the more times this gets called. The less your computer is doing, the less busy your computer is, the more times this gets called. So when we're doing something that's physics related, like add force, Unity has another built-in method that they prefer you use called fixed update. And so we can change the comment here and say fixed update is used for physics actions, right? and it just normalizes the speed now so that on a really fast computer, this will be the same speed as on a really slow computer. So that's ideal. That's what we want. We don't want the speed of your player to be dependent on the speed of your computer. So we're using fixed. I meant to use fixed update here, and I meant to make that comment. So forgive me. I'm human. Okay, then let's jump back to our camera controller here. So in camera controller, we are going to use start. Okay, and we're also going to use a different update function, not fixed update or update, but we're going to use another one. But before we get there, let's add we need two variables here. One is, remember, we want the camera to follow our player around, right? That player is a game object. Everything on our scene is considered a game object in Unity. So what we're going to do is we first need to target that player. So we're going to add a variable here, player, and this will be of type game object, and then we're going to call it player, right? Just keep it simple. It's our dude, it's our ball, whatever. Then we're also, what we want is we want the player here and the camera here. So we want them to be offset by some distance in all three directions, right? So we're going to calculate that. We don't need to show anyone that, so we're going to make that private. It's going to be one of these vector3 objects, and we'll just call that offset, right? So now we've got those two variables, and now when our player and our camera are first rendered on the scene, we want to calculate that offset. So we're going to do that, and we're just going to say, again, this script here is attached to the camera. So if I just talk about the transform, it'll automatically know that what I'm talking about, if I pop back over to Unity, so I'm on the camera, if in this script, if I refer to the transform, it's referring to this component of this game object that we're already in, which has the position and rotation and scale in all three dimensions. So I can access that just by saying transform. So if I just say transform, it knows I mean the transform, in this case, of the camera. And I'm going to get the position of that. And I'm going to subtract it, get the difference from, now I call my player game object its transform position, right? So this is, it might be a little bit easier to read this if it said camera.transform.position minus player.transform.position, right? So it's showing you here's your player, here's your camera. Take these two, we don't care where in the world they are, just look at the difference between them, right? That's our offset. And that offset is, we want to keep the same. We want to move that as the ball moves around, we want the camera to move around, right? So then what we're going to do is on every frame, essentially, as the player moves, we want to update the camera. And what we're going to do in Unity, I told you it has all these different update methods. There's update, there's fixed update like we just used for the player. There's also two, that one is called early update, which kind of happens before all the physics is calculated. And then there's late update, which happens after all the physics is calculated. That's what we want. So if I act on that ball, I act on the player to move it forward. After it updates it each frame, then we want to update the camera. So we're going to use, in this case, late update, right? So we'll just say, I'll just put here in the comments, late update is called after physics are calculated. So late update, what we're going to do is we're going to say, well, move our camera, our transform position, set it equal to wherever the player ended up, right? Where did the player end up? plus our offset, right? So all we're doing is we have the player and the camera, and they have some distance between them. Let's call it the offset, right? Which is represented by my pen. And what we're doing is we're saying, okay, move the player. The player moves, somewhere else. And now take the position of the camera and move it to wherever the player is plus the offset. And so the effect will be that the camera will follow the ball around at a fixed offset. And this should work, but let's test it and make sure. So hop back on over to Unity. Again, it'll take a sec while that is compiling. And if we hit play now, as our ball moves forward, oops, our camera doesn't move. So why not? Why did that happen? Well, notice we created a public variable called player, right? That's a game object, and this is supposed to point at what we're following, and there's nothing here. So there's a lot of different ways we can set our ball, our player guy, in here. One is to grab it from our hierarchy here and drag it over. But the problem is I clicked on it and now I don't have my camera over here. Another way to make it a little easier is they have this target here, which you click and it shows you everything in your scene. So we can just choose our player from there, and now it's linked up. And now if we play, I move forward and the camera moves forward, right? I move side to side and the camera now follows the ball, and it has a much more smooth and natural feel, right? Little slow for me, so I'm gonna crank the speed up. I think, it had been set at 6 still. So okay, so now we've got our first two parts underway. We're controlling our player, we're controlling our camera, right? We're really starting to develop this scene of just primitive items into a game. So what's next? The next thing is I have this cube here just to interact with, just to show you the physics that we can bump into it. We can cause it to tumble, things like that. But that's not really what my interest is. So I'm going to delete that guy. What I want to do is I want to focus on this one here. Let's zoom in on this guy a little bit. This object here, okay, which we can, notice actually because it's rotated, if I go to lift it up, oh, there we go. I just had the wrong arrow. So we're going to take this guy and we want to make this like our coin object, like our collectible, cool, fun thing, right? So it's bright yellow so it stands out, but to really make it stand out, let's add a new script to this and call it Rotator. And we want this thing to be spinning, right? So it really grabs our attention as something like, ooh, I want to go grab that, like a gem or something, spinning in a game. So we're going to create this Rotator script. We're going to jump in, and what we want to do, we don't need anything to happen on start, right? We already have it in the position we want. But what we want to do is we want to now not change the position of this item like we were doing with the camera and with our player, but we want to rotate this, okay? How much are we going to rotate this? Well, we got to use our vector 3, right? And I'm just going to give it some amount in the different directions, 15 degrees, 30 degrees, 45 degrees. And again, because update depends on the speed of the computer, a lot of times if you do things in this update function, you multiply them by something called time dot delta time. And delta time, which lives inside the time object, that tells you how, like, the time slice between frames. So this is getting called once per frame. Well, we want to shorten this so that it doesn't, if we multiply by delta time, it normalizes this for the speed of the computer. So the speed this rotates at should look the same on any computer. So if we hit play now, oops, I got a compiler error. So that's good. So I come to my console and it says there was a semicolon expected. Yes, I program in JavaScript where all the time where it doesn't care if you have a semicolon or not at the end of the line. C#, it does. So with C#, if you don't have a semicolon at the end of your line, you've got an error. So let's flip back over and boom, my error is gone now. I hit play and now we can see this guy is tumbling. Right? Well, hopefully you guys can see that online. So now I've got it spinning. If not, I could come over to my scene and you can see it real big here, right? So we've got this spinning object now, and this is what I want to go. I want my ball to go around and collect these things and add to my score, right? So now this is attractive. It's more exciting, more attractive to go pick this thing up, right? So now we're going to add some more action to this by allowing our player to pick these up. But first, what I want to do is I want to take this collectible item here, and I want to make since we're going to be making a bunch of these, if I go into my assets folder, I created a prefab folder. In Unity, we use prefabs because if you reuse objects over and over again, you can, if you create a prefab, which I can do just by dragging that object down here into my assets, and now I have a collectible object that if I make multiple copies of it and I edit one, I can have it apply to all of them. So that's really the power of prefabs, is where we can like change something about this collectible and have it change all of them in our entire game. So let's zoom out here, and what we want, first thing we want to do is we want to take this and let's first make an empty game object. I right click and say create empty. This is just like to be a folder, as if you will, and we're just going to call this collectibles. I'm going to put my collectible object under that. And now I'm going to duplicate a bunch of times, right? And now I can drag these around my scene and add these, kind of scatter them around in different places. Oops. Like so. So I'm just gonna let's look from above. So actually make this a little easier to do, and I can plop these all around. Maybe like so. Okay, there we go. So now I have about a dozen of these around, and let's just play the game and see what happens. Now I have them all rotating, right? They're all exciting, but I don't have any interaction set up with these yet. In fact, I don't even have them set up to collide. So let's now go into one of these collectible items and look at why. So, well, actually, I kind of like that they're not set up to collide. I'm realizing I made a couple of changes here that I shouldn't have made pre-video, but hey, you know, we live and learn. So let's actually, what we're going to do, we're going to go back to our player and we're going to edit our player script. And we're going to add a brand new function here in our player that what we want to do basically is we want our player, as it's moving, we want to detect and see if it collides with anything. And if it collides with something, we want to gobble that thing up, right? We want that thing to disappear off of the board. So there's a function that gets triggered when collisions happen called onTriggerEnter. Okay, and a lot of these things that I'm just telling you, these are all in the Unity documents. You know, you can search the Unity documents for collision, and it'll give you all the different functions you can use. The one we want is onTriggerEnter, and what it's going to do is it's going to pass you a collider, and we're going to give that a name. We're going to call it other. It's like the other thing. It's not the game player. It's the other thing that we collided with, right? And that's going to be our function here. Now, what is the collider? If we hop over to Unity, if we look at one of these game objects, you can see it has a box collider. And I'm going to turn off isTrigger because by default isTrigger is not on. So I want to make sure that that's not on. And since I've now changed the prefab, I want to say apply this to all, and now every prefab has the trigger off, right? And so now that's what it's going to refer to. When I collide and it gets that other thing, it's going to be getting this. So I have access now to this object here. And by the way, I've tagged these all. I created a tag. You go to add tag, and I created a tag called collectible, and I applied these to all of them. And that's going to be really useful. These tags and layers can be really useful. So we're going to use the tag collectible because our player is also colliding with the, why is it, hello? There we go. Sorry. Sometimes it's a pain to navigate in 3D. Our collider is also navigating with the ground plane here. It can collide with these walls. We definitely don't want to gobble up the ground plane when we collide with it, because then as soon as we hit play, we're going to gobble up the ground, fall through, game over, right? Or with a wall. They're there to keep us from falling out. So if when we hit them, we gobble them up, they're gone, right? So we don't want that either. So what we want to do is when we collide with something, we want to make sure that it is tagged collectible, which I've already done. So let's write that into our script. So we're going to say, you know, what we have here is we're going to have other now. We can actually access its game object like this, and we can access its tag like this. So what we're going to actually do just to start is I'm just going to say write to the debug log, right, which is the same place that my errors appeared where we looked at that console. I'm going to say log out this game object's tag whenever we collide with something, okay? And I'm going to, let's jump over to Unity. Let's hit play. This isn't going to work right away. Whoops. Method must have a return type. Right. Yes, yes, yes. This is not returning anything like these, so we need to tell it the return type is void. So I could create this new method here, but I just need to add void there. That's all that error was telling me. So now we hit play. I've got another error. What the heck? Debug does not contain a definition for log. Where is my... Oh. Yeah. This is the problem with switching between different programming languages all the time. Log should have a capital L. That was the, it was recognizing debug, but not debug.log with a lowercase. Now my errors are cleared up. But here's the thing. Notice my player is colliding with the ground, and I'm not getting anything in the debug log. I collide with a wall, and I don't get anything in the debug log. I collide with this item, and I don't get anything in the debug log. So what Unity has is, in order to keep the, from firing this collision detection constantly, they make you to tell them if you want to trigger the collision detection on trigger that we just created for certain types of odd items. And in order for the object that we're colliding with to be one of these triggers, we have to tell it. We have to go in and say, right here in the box glider, we have to say this is a trigger, right? So we hit that, and that we're turning it on for collectible number 9, which now is overriding our prefab, right? So we want to say apply it to all. Now all of the prefabs are triggers, and what we should see if we play now is the same thing, except in our console log, we should get the tag for each item that we collide into. So if I collide into, this is why I don't play games. So I collided into that, and in the log, it's saying collectible, collectible, collectible. So that's what we want. But what we want to do is not look at this tag, but what we want to do is we want to say if that other game object, and then we can say tag is equal to collectible, or we can use a built-in function called compare tag, and then we say collectible. So if this is basically saying if the tag is equal to collectible, then what we want to do is on that other game object, we want to set active to false. So there's other things we can do. We can use to destroy that game object, but what I actually want to do is I want to go in there, and I'm going to get rid of this debug log. What I want to do is if I hit that game object, and if that game object has this tag collectible, I want that game object to become inactive. What do I mean by that? Well, let's jump over to Unity. In Unity, an object is active. This is the checkbox right here to say if it's active. And if I click it, object is gone. It's no longer active. Now it's active, now it's not. So that's a way in Unity to just kind of like make the object not active. So now when I roll into it, it's gone. It's gone. And so now I can actually start to collect these objects, right? So that was the fourth part, was making these things triggers, detecting the collision, making sure that the collision was for the collectible object, and then taking that object off the scene to eat it or gobble it up or whatever you want to think of it as. And now we're going to do one last thing here, and that is, notice as I was playing and running into these objects, my score's not changing. So that's what we want to control. That's the final thing that we want to control. And in order to do that, what we want to do, we're going to need a few things. First of all, we need to be able to point to that text up at the top where it says score is 0. So we want to create a public item because we need to refer to that text object, and the text object is and we'll call this score text. The text object, though, is not part of Unity Engine. It's part of Unity Engine.ui. It's a special UI element. So we now, in order to reference that, we have to bring in this UI library in order to act, because this is not a type under Unity Engine. This is a type under Unity Engine.ui. So if we don't bring this using Unity Engine.ui, it won't know what this text element is that belongs only in the UI engine. So we're gonna have this, and we're gonna have to tell it which text element we want to display our score in, and then we're also gonna create another private variable, which we don't need to access outside of this particular component. We're gonna make this an integer, and we're gonna call it score, right? And when the game starts, we want to set score to equal to 0, right? At the beginning of the game, the score should be equal to 0. And now we want to display it. So how do you display it? Well, we're going to refer to this score text object, right? And if we go back into Unity, hello Unity, there we go. And we look at this text object here. So this text object also has components, one of which is the text, right? So we want to get this text element dot text, and that's what we're going to refer to. Text element dot text. We're going to set that equal to score, and then we're going to add our score, whatever our score is. So initially it's going to be 0, right? And then when we gobble up a collectible item, we also want to increase our score. So we're going to say our new score is equal to whatever our old score is, plus, let's say, 10 points, right? 10 points for Gryffindor for scoring the snitch. And now we also have to do the same thing as here, right? We've got to update our score text with the new score. Now, anytime you repeat code like this, it's usually bad practice. So what we might want to do is we might want to create a whole new method here called set score, right? And put that code in here, and now instead of writing this, we can just call set score in both places. So now we don't have to repeat our code more than once. So if we want to change this, we change it in one place, and we don't have to change it anywhere else. So now what we need to do is we need to link up score text in our component. So let's plop on over to Unity. Let's grab our player, right? And here it doesn't have anything defined for our score text. So we're going to drag this text over there. And now let's play and see what happens. Boom, score 10. Score 20, score 30, score 40. So there you have it. We went through, hopefully you guys are with me here. We handled player movement just in a really simple way, camera tracking in a really simple way, and there's a lot of pre-built scripts for this that you can use. We handled object rotating, collision detection, and scoring. And that's what we have for you today. Again, I'm Todd Albert from Boca Code, and I thank you so much for joining us. And hopefully you guys learned something.